We are not.
You guys were in Seattle.
Turns out you were in Seattle, what I'm sure was an awesome trip. Much more fun than just going over the Agate Street. Let's see. We're not going to talk about hand media today because that's pretty intuitive stuff. It's a lot more easy to figure out, how watercoloring works as opposed to clicking your way through Rhino and Photoshop and all that sort of stuff. We're also not covering any of the fabrication resources at the school, which if you haven't made yourself familiar with the laser cutter down in the wood shop and all the tools in the wood shop, you should definitely do that. I'm sure you probably already have with your construction projects and all that. Also, it's very good to be aware of the craft center over in the EMU. There's another extensive wood shop over there. There's also a glass blowing studio, ceramics, all sorts of stuff you can potentially use and bring into your projects. So yeah, like I said, this event is sponsored by the Design Communications Task Force. One of the things we're working on in addition to this event is something that Noah put a substantial amount of time into. This is the Architectural Media City website. It's just archmediaexplosion.com. And the idea is that it's a source for online tutorials, inspirational and professional development tools, and a lot of this content, these handouts that are here for you have also been put up there. Not yet, they will be put up there. So if you lose track of printing one, pull that stuff back, you can track that down. Let's see, the last plug I have to make is for the Graduate Technical Teaching Certificate Program. This is a program that's run by Allison Kwok, who will be teaching your ECS course this winter. And she's a great lady. Many of the presenters tonight are pursuing the certificate. It's a great way to gain teaching experience, augment your master's degree, and get the most out of your technical education. If you have questions about this, have any interest in teaching whatsoever in the future, definitely ask us about it, look into it. This week, actually Wednesday, I'm pretty sure it's still scheduled for Wednesday because Allison's been out of town. But Wednesday at the Hard, 5:30 to 7, there'll be some food and it'll be kind of a reception going over the basics about what the tech teaching certificate's all about. And then this coming Saturday, we have an all-day seminar. It's worth a couple credits, and I know you guys have your credit load is full currently. But if you speak with Allison, there's a chance that you could potentially get those credits counted towards next term, so they could be used as your two extra credits next term beyond your core requirements. Anyway, that's enough of all the plugs and all that. What this event was really conceived to help you with is to avoid this sort of thing, and this sort of thing, and we definitely want to avoid that sort of thing. Don't want any of that going on. That was me, like I said, a good portion of last year. So I kind of got motivated to try to do something about it. But really, the way the curriculum is set up right now, within your core media education, this is the only digital media course you're going to get. And it's really frustrating, I'm sure, as you've come to experience, because you're trying to learn all this stuff in one quarter, and it's kind of trying to drink through a fire hose, right? Where you're just getting blasted with so much stuff, and you guys haven't even got into the grasshopper world yet, I'm pretty sure, right? So what we're trying to accomplish tonight is to give you an introduction to some of these tools, as well as an understanding of their potential, and attempt to help you, to help your motivation as you take up the challenge of learning them all. We also hope to maybe provide a little inspiration in the form of seeing what some of your classmates are doing, what you might want to aspire to in the next few years. For a lot of us presenting tonight, last year was the first time we were exposed to a lot of these tools, and so here we are a year later, kind of showing you the ground we've covered. Is the idea. The way things are going to work from here is that we're going to have 6 or I guess 5 short presentations going over various topics, and we're hopefully going to get through those pretty quickly, and then we'll kind of have a breakout session where we'll all be kind of hanging out and hanging by these posters and chatting with you about stuff that might pique your interest. After we're done talking. There's also handouts here that kind of get at each one of the little programs. I know one of you had asked about which program should I use for this, which program should I use for that. That information definitely comes through in these handouts, and we can kind of go over that a little more if you guys ask questions throughout today's little video. So I'm going to toss it over to Mandy, who's going to come up and talk a little bit about Photoshop and the Creative Suite. Mandy is another track one.
Okay, before I start, I just wanted to kind of get a feel for what you guys know about the Creative Suite. So can you guys just raise your hand? Who knows Illustrator? Photoshop? InDesign? Okay. So that's good. That's what I was looking for. I'll talk just quickly about InDesign and Illustrator, and then I'll kind of dive into Photoshop. So InDesign is the best program for you to use when you're creating layouts for your presentations. And that's because there's just so many handy tools for placing images, placing text, organizing multi-page documents. There's really nothing that can compete with how easy the program makes it. And then another really cool thing about it is it links images into a larger file, so your files aren't huge, and whenever you change an image that's saved somewhere on your computer, it will update it in your folder. So there's kind of like a bunch of little tricks to InDesign that really make it handy when you're trying to compile large amounts of work. Illustrator, there's a lot of really specific uses for Illustrator, but it can be really handy. It's a vector graphics editor, which means that you're editing points and lines and fills, versus something like Photoshop where you're editing raster images and pixels. So Illustrator has, like I said, a lot of like really specific uses, but some cool things that I've seen done is you have a hand sketch and you bring it into Illustrator, and it'll turn that hand sketch, rather than being pixels, it'll turn it into a vector object, and then you can resize it without it losing any quality. So you can have, lossless images that can be sized without ruining the quality. It's really great for logos and kind of simple, very line dominated or fill dependent images. So, and I'll kind of dive into Photoshop more. It's a raster graphics editor, so you're dealing with photorealistic images and you're working with pixels and editing those versus like Illustrator. So Photoshop is used by a variety of different people and a lot of photographers and any sort of graphics related art is going to use it, and so I decided to throw in just the basics. A lot of you probably know this. You can just crop, resize, change colors, all of those kind of just kind of commonly expected things for when you're editing photos. So for those of you who have experience with Revit or other 3D modeling computer programs, it's really difficult to get to the point or to the stage where you can produce really great images just straight out of that program. And so, because I'm one of those people that's not great at creating these really gorgeous 3D models straight out of Revit, I call it, I get out of it Revit Cube, and it's basically just like the spit out of what your model is. And so I rely heavily on Photoshop to be able to take that image, or you'll take like an image of your 3D model and you'll throw it into Photoshop. And for this example, I had that photo already, and I kind of merged my 3D model into it, and I added the little snowmobiler, and you manipulate things like you throw reflections of the clouds into the windows. It's really, kind of subtle, but little things like that. You can manipulate colors, which is it can be kind of tough when you're working just in a 3D model. So you just kind of tinker, and it's a lot of fun once you get to know what those little tricks are. There's a lot of different ways to do the same thing in Photoshop, so once you get more experience, you can definitely find time-saving sort of things. So if you guys have any questions, maybe you do know how to do something in Photoshop and it takes forever, there's probably an easier way. So if you wanted to ask me any questions like that, I can probably help with that. This is another one. You can take, when you have a studio and you have a specific site, that other one wasn't specific, but this one is, and you can take a picture of your 3D model from the exact angle that you take a photograph of your site, and you can throw it into Photoshop that way. And in this example, the top right image is what I got out of my 3D model, and it was terrible, and it was the wrong color, and it wasn't very expressive. And so by tinkering with it in Photoshop, changing colors, adding the people, adding interiors, kind of overlaying kind of the urban context in front of the building, it can really help describe what your building's like to your reviewers. And so I think in that way, Photoshop is really helpful because it can kind of bridge the gaps that you have in maybe your skill set when you're trying to describe something to a reviewer. This is kind of a nice trick to know. If you're working with a model and your model doesn't quite describe what you want, or you just want to kind of overlay some information onto a model, you take a picture of your model and you want to throw it into your presentation. These are two examples of that. I had this kind of hideous little model. It's the top left image, and I took a picture of it, and it's slightly edited in Photoshop there. But then just with some simple overlays on the top right, just throwing some simple colors in and kind of just hinting at textures and materiality and that sort of thing. And by putting the people in, you get this really quality, really quick thing to describe an interior. And the bottom, it was just a really quick way of throwing color on to be able to describe like a circulation path with that same model. So just by merging those two techniques, you have this really quick but really descriptive piece of information to throw onto a presentation. And then I just wanted to show an example of combining media in another way, hand drawings plus maybe a photograph or a 3D model. It's really simple to do with Photoshop, and there's ways. This is kind of a kind of elementary way of doing it. This is it's sort of unrefined, but it's just a quick example of what you can do. And there's really great tricks for using filters and changing the tones and everything to really make those merge to where they're almost like this. You can tell, you know, the separation between the hand drawing and everything else, but there are some tricks that I could show you if you're interested to really make those two things merge together. And so that can be really a really great tool or a really great technique to use. And then adding color. These are just quick concept sort of gestural little thumbnail diagrams, and you'll be amazed just by throwing it into Photoshop and just throwing some color on how impressive it can be on your presentation versus just black and white. And you can also add color. So like I know some people are kind of scared of throwing markers onto a drawing that took them forever to do. So throw it into Photoshop and you can edit your materials or your colors, or and it's a really easy way and forgiving way to do it.
My name's Annie. I'm another second year track 1 student, and I'm going to tell you about printing, which I think most of you have figured out where all the printers are. We just got a new color printer in the DCL by DCL1, so you don't have to wait for the library to be open to print in color. And then we have standard in the DCL and the AAA library. And if you don't have a DCL code, you should get it in architecture. office. The DCL is open 24 hours. How many people have set up the printers to the computer? Okay, good. I like to go for that. You guys know how to deposit cash into your account. Important thing, I don't know if you guys have printed posters from the output room already, but you should always change it to PDF X 3/2003 because they will not print it for you. They'll just ask you to change it again. And if you go into the server and you click on, when you type in AAA file server, .uoregon.edu, and you click on AAA prints, and then you pick your paper type, just drop your file in there, and then you have to go release it at the output link. You don't have to pay for the print until they print it out for you. And then this is a tip that I'm pretty sure Phil will remind you, is that when you print a large poster or a rendering, you should always change the resolution, which you can find under image size. Because you don't want to print out a 24 by 36 rendering and have it super pixelated when you spend hours and hours on it. So definitely go into resolution and change that. This is about scanning. So when I scan a document, I usually manipulate it in Illustrator or Photoshop. And so this is a raw image of the scan, and this is the image in Illustrator using image trace. So trying to make scan diagrams look consistent, I would just manipulate it to look more black and white and consistent with the whole poster. And some other helpful tips. If you're going to print anything bigger than 5 megabytes using the subsurface printers, it's going to take a really long time, so make sure it's compressed. And the output room can also do free test prints. So if you have a big poster that you need to print, you can always print out a test strip for the output room, just ask them what they need and change that. And try to get your poster ready for print early. So I had a traumatic experience in the spring where the output room was used to its max, and they ran out of standard map, and so I had to use Mylar, which is much more expensive. It turned out to be over $100 to print that poster. And I always recommend trying to get your poster done early because you don't want to go to Kinko's. Kinko's is probably twice as much as the output room. I've seen people having to print their poster at Kinko's for $200 when they only cost $100 here. So make sure you use the output room and get it in early. Any questions about printing?
Yeah, and the handout, that's the printing handout, I've found super helpful already, just because you always forget about that stuff and where the server file is and all that. So.
Cool, right on guys. My name is Luke. I'm going to talk to you really quickly about 3D modeling and using those programs as a tool for design development. We're all aware of the final images that we can get, and we can see the power in that, but there's a lot to be said for using these tools to help you iterate as you move forward and coming up with a good solution to whatever your design problem is. So before I get started, I'm just going to talk real quickly about the 3 different types of 3-dimensional modeling, just so you have an awareness of what the different categories are. The first one is surface modeling, which programs like Rhino are using that interface. You guys are all using Rhino, I imagine, through the service or the license that the school has, which they just kind of started with us, which is exciting. Surface modeling is great for doing things that are very specific, very precise. It works great in 3 dimensions, as you all know with Rhino, but the problem with it is that also you make leaky models and that they aren't necessarily unified across all the joints. You can have problems when you export them into other media. Surface modeling is also known as NURBS modeling, which is a non-uniform rational bias system, just so to have in the back of your mind, be aware of what NURBS modeling is. And you have solid modeling. Programs like SolidWorks and CATIA are going to be doing this type of modeling. It's also known as feature modeling, and what you're doing is you're actually defining real geometry. And so as you are inputting data into the program, it's generating a real thing. It's a non-leaky model. It's easily machined. It's ready to be exported to CNC machines. And it too has a high level of precision. Programs like SolidWorks are parametric in the way that they work. CATIA's too, I guess. In that you're building the relationships between the parts, and then you maintain a level of adjustability, but still in the end it's creating solid geometry, and that's a significant part. And lastly, you have polygon modeling, and this is what most of your animation software is going to be. A lot of your trick rendering software is going to be using polygons. It's also called box modeling. It's quick and conceptual, and what you're really doing is you're starting with primitives and you're affecting those primitives. So you start, it's more of a sculpting process, rather than just in the surface modeling, you're going to be drawing an outline and then creating a surface off of it. Whereas in polygon modeling, you start with the shape and then you affect it to get your desired effect, and then you can patch it between different components. And so those are the three main types of different modeling tools, which is important. So I was talking earlier about parameter-based modeling or parametric design, and as a quick explanation of what that is, I'm going to talk to you about a simple problem, which is designing stairs. We all know that stairs the whole point of stairs is to get from one level to another. So you have to change over a y distance, over a vertical distance, and it can be defined through an equation. Like there's a real relationship between the amount of steps that you have and the distances that you're going to be moving. So what you can come to do is start making definitions where you aren't defining explicitly what you're doing, but rather allowing for a level of adjustability. And so that lets you, in your design process, have the freedom to manipulate iterations. And you can start to come to see how when you work on larger scales, you can satisfy a number of conditions. This is a very simple explanation, or a very simple example, but I think you can come to see kind of the concept. I'm quickly going to go through a project that I worked on and just talk about some of the tools that we used to accomplish it. We were trying to design a roof pond that was a passive thermal strategy. And what we were doing is we were making a roof pond that had three different states of condition, where it can be charging, where it's accepting energy, where it's re-radiating, where it's being covered by an insulating member, and it's re-radiating heat into the space. And then there's a third condition where the roof pond itself opened up, and it would be able to ventilate the space. You can charge, radiate, and purge. And so we went through a whole design process of trying to figure out how we're going to accomplish these things. And so, as is always a good strategy in my mind, is don't forget about using a pen and a pencil. Like, start with the simple ideas, figure out your relationships, figure out what you're trying to accomplish, but then start to put some rigor to it and start to try to define what you're doing. And so this was us looking at the possible, or the potential within that roof pond system, which we broke into a series of bars, and we had their rotations all related to one another. So we wrote the definition of Grasshopper to be able to model that relationship, but then we could affect different parameters and do it in different capacities and get different sculptural gestures. So we were able to use it as a vehicle to test the possibilities within our design solution. And then what you want to do is you want to take a step back. Once you figure out what the overall larger gesture is, you need to figure out how do those details actually work. And so our workflow went back to the paper where we said, okay, how do we make these individual bars perform in the way that we want? And so we went back, started to rough out dimensions, figure out the way the thing's going to be working, and then we took it and we imported it into SolidWorks. And SolidWorks is an interesting program because, like I said, it's solid modeling, but additionally what you can do is you can create different features and put relationships between them so you can actually animate them in a mechanical fashion. So you're able to create gearing systems and you're able to create rotations. And it was a way for us to very quickly test different ideas and to see what would be a reasonable solution. Granted, this is more of an engineering problem than an architectural problem, but I'm sure you guys are clever enough to see how there's lots of crossover between the two. So then what we did is, after we figured out that geometry and got to work in SolidWorks, we imported it into SoftImage, which is a polygon modeling program, and set it up so that it could be rendered. And so then we created the topography, which is actually imported from Rhino, but that's beside the point. And then we had the building, built it all out, and were able to then create a larger project where our whole entire system was now integrated, and we were now moving into a phase where we were trying to present what it was that our concept, or present the concept that we developed up to that point. And that's pretty much it. I've got a animation of that project that I can show you guys afterwards that kind of ties together after seeing the different steps, and I can talk about the individual tools that I was using to develop the design through our process.
All right, I'm going to talk a little bit about Rhino and why it's kind of become the program that's been embedded in our curriculum here. 3D modeling softwares, there's a lot of them out there. There's SketchUp, there's AutoCAD stuff. But the thing about Rhino is that it's open to third-party plugins. The biggest one you probably heard of is Luke was talking about Grasshopper just earlier. But to start with, even before we get into those plugins, you guys have gotten into Rhino a little bit. I hope you guys have come to realize how fairly user-friendly it is. If you haven't realized, this command bar at the top is your best friend. You type in any command and hit enter, the commands are just going to the command bar is just going to walk you through what your options are, what you can change, and all that sort of stuff. It's got all the viewports, so you can zoom around real quick. I'm sure you guys have had a little bit of experience, walk through one or two of those tutorials on this right now. One of the great tools is Make 2D. Have you guys gotten into all this stuff yet already? Yeah. Okay. So in that case, here's an example of the Make 2D thing. I put it in Illustrator, all that. But getting into the plugins, here is Grasshopper, which is what Luke used to create that stair script that you guys have been getting into a little bit. And it's kind of hard to wrap your head around, or at least it was when Philip was presenting it to us last year, of like why you want to use this tool. And Luke's example of changing those stairs and experimenting with stair heights. And the cool thing is he has that stair script. He's got in his back pocket anytime he's building a model in Rhino where he's going to need stairs. He can just pull up that script and generate a stair super quickly. Same sort of thing can go for handrails. Same thing can go for window mullions. All that sort of stuff. Here I used it to actually construct an entire wall, just defining it off of one line. So actually everything you see in the bottom frame was scripted in Grasshopper, but I needed to build a wall that went between this covering fabric and it connected this curve going around this whole space. And what I was able to do is take that curve as my starting parameter and split it up into so many parts, extrude so many columns, and so instead of having to go around and click and copy and paste each little column all around this line, I was just able to split the line up and divide my geometry building it off of that line. So those are a couple good examples of why you actually want to try to learn Grasshopper to do more than just perforated picture panels or whatever it is Phil's going to have you do. This is another plugin. You guys are going to get into V-Ray, I imagine, which is the really popular rendering software. This is Maxwell, is another software that's out there. That's a plugin. Most of these softwares have free student versions or free trials where you can get into them, experiment with them enough to decide if you want to keep working with it or not. But the way they work is you have all your different layers in Rhino, and if you haven't realized in all of these programs, managing your layers is like the most important thing you can do. So you just take away all of that one item that's all on one layer, and it makes life so much easier. So get familiar with your layer interfaces and how to do them in every program. And here, so the way most of these rendering engines work is you have these assigned materials and properties to all of your layers. Like that, the glowing stuff is a fabric. There's all these lights inside of that structure that are coming out. There's little wood mullions on all the columns and all that sort of stuff. So it gives you an idea. That was a render that was then tossed into Photoshop. Trees and people were added. So just give you an idea there. Another plugin that is super powerful, and it's something that I'm really into and excited to really explore some more, is Diva for Rhino, which is a thermal and daylighting analysis software.